Oh, drat these computers. They're so naughty and so complex. I could pinch them.
What's up, everyone, and welcome. In this episode, we're going to talk about the DarkRadiation ransomware. On June 17th, 2021, Trend Micro came out with a report about a new ransomware called DarkRadiation. It was initially reported by Twitter user, I believe it's Red Buzz, I'm not sure. Upon investigating, they found that the attack chain is fully implemented as a bash script. But it also seems that the scripts are still under development, so things can change. Most components of this attack mainly target Red Hat and CentOS Linux distributions. However, in some scripts, Debian-based Linux distributions are included as well. The worm and ransomware scripts also use the API of the messaging application Telegram for command and control communication. In previous episodes, I've actually talked about, if you recall, Windows-based ransomware relying on PowerShell. So it's only logical that with the increase in attacks on Linux-based systems, someone would put together a ransomware package relying on bash. Now, we want to make sure we are secure and prepared in case one of these attackers tries to infiltrate our system. So today we're going to take a look at this ransomware and see how we can protect our systems and clients from it. Let's take a quick look at the agenda. As always, the first step is to look at the definition. What is DarkRadiation? We'll then move on to the anatomy of the attack. How does it work? And we're going to finish up with what can I do, steps to improve. Before we jump in there, here is a short list of some of the resources I used to create this episode. They all kind of have sometimes different takes on it. They all kind of have different snippets out of the full report. Not all of them have exactly the same insights themselves or implications. But going through all of this and doing the research, we have put together a very clear, concise picture of how this works. Now, you can certainly spend hours researching this on your own, or you can sit back, enjoy, and benefit from my work. But make sure you pay attention, especially because if you are relying on Linux-based systems or Docker containers, then this ransomware affects you directly. So, what is DarkRadiation? DarkRadiation is a new ransomware, really new. It appears to have been first noticed in late May 2021, so just a month ago, by a Twitter user, again I believe it's pronounced Red Buzz, and was later reported on by researchers at Trend Micro. It appears to have come to light as part of a set of hacker tools through discovery on VirusTotal. At this time, there is no information on delivery methods or evidence of in-the-wild attacks. However, analysis of its various components suggests that the actors behind its development intend on using it as a campaign targeting Linux installs and Docker containers. So, pay attention. Let me take a minute to give you some powerful reasons why you should share this video. Now, if you have seen this before, feel free to skip to the next section or just enjoy it again. If you haven't seen it yet, I want to show you how you can be a superstar in your team and your company just by sharing this video. First off, I really appreciate you watching this episode, liking it, and of course, subscribing to my channel. But I ask you to share it through any and all channels you have access to, whether Facebook, Twitter, LinkedIn, YouTube, Pinterest. You can link to it from your websites or even send it in an email to your colleagues, friends, and family. If we can spread this information to enough people, we all together can work to make the internet more secure. So, share it with developers in your team or developers that you know so they can integrate the security measures I will outline in this episode directly into their workflow. Share it with quality testers in your team or ones you know so they can benefit from this information and improve things like writing their acceptance criteria and test cases. Share it with project managers and product owners so they can make sure projects have the right security principles in mind and can talk intelligently to stakeholders about the importance of these measures. Share it with CEOs, VPs, and managers to show them that you're on top of these topics, taking them seriously, making you look like a superstar in their eyes. And finally, share it with your mom, dad, grandma, or friends, or anyone you can think of. Keeping them safe and helping them have a safer experience on the internet will definitely save you time and headache. Now, if you haven't already, right now is the perfect time to pause this video and share it before we really get deep into the content. Thanks again for your support. So how does it work, you ask? We're going to look at a relatively visual representation to kind of break down the steps and break down the pieces. We're also going to dive into the actual scripts themselves to look at them and see how they function. But if you were to look at an overview, it really comes down to this is a ransomware that's based off of a group of bash scripts that work as follows. So first, the attacker has to gain access to your system. So there has to be some other vulnerability on your system for them to gain access. Once he has access, he's on there, he's on command line, he's going to first check to see if he has root capabilities. If he doesn't, if the script doesn't have root capabilities, it exits and deletes itself. Okay? So locking down root access is one remedy here. Once it figures out that it does have root access, it checks if curl and OpenSSL are installed. And if they are not, since it has root access, it installs them using the yum package manager. Once those are installed and it knows, okay, it needs OpenSSL and curl to do specific tasks. Once it knows those are there, it then begins the process of mapping all of the existing users and communicating that to the command control server. Now, let's say it grabbed a list of all the users, and in 30 minutes some new shell account opens up. Since it's going to check every 5 seconds, this new account will be compared to the list of existing accounts, and if it does not match, if it's really truly a new account, that's also reported via the Telegram API to the command control center. So it's actively checking for anybody who's accessing the server and communicating that user's information through to the command control server. Once that is done, it stops and disables any Docker containers that may exist. It also deletes the var-lib Docker folder. Once all that is done, that's all the prep work, it begins the encryption process. It grabs a password, an encryption password from the command control server and begins encrypting various files and folders like root or home, things like that. Once all of that is done, it then creates and shows the ransom note. Now, it is important to note and stress again that this appears to still be a work in progress. So there are a number of pieces that can change or act differently depending on which version is used. They could theoretically mix and match different pieces of different ransomware and combine it with a shell script, various pieces of the shell script. So it doesn't always have to stay a bash shell script ransomware. For example, looking at it from another direction, the encrypted folder location does change between variants of this software, of this ransomware. The Linux operating system can be changed, and other pieces they could just change. They could come up with a better version, or a better combination, or a new combination that doesn't have a fingerprint that could be noticed by any anti-malware or anti-ransomware software. So let's take a look at a visual example to understand it in more detail, and then we'll check out the scripts and how they work. Okay, so you have your website or a web server or some server that is infiltrated. The first thing that's going to happen is the attack starts with the attacker, of course, gaining access to the system through a vulnerability in the system itself. The second thing that's going to happen is he's going to run that to check to see if he has root capabilities. If there are there's no root access, then, like I said, the script exits and it deletes itself. So it just gone. The next thing that happens is to check if the curl and OpenSSL are installed. If they're not installed, it installs them. And once that happens, the real sort of process begins. Like, this is all precursor stuff that is required in order to be able to do the rest. So now we begin. Up here, you can see this is the main function, and within there, one after the other, it says check root. That's what we did. Done. Check curl and OpenSSL. Done. And then it begins another task, which is the bot who script, which maps users and checking every 5 seconds for newly logged in users, and then it reports those changes to the command control server, which is up here, say outside of the system, outside of the network. The next task is to disable, and some variants actually delete, all users except for the attacker user, of course. And then it disables any shell users who may be logged in currently. It then follows it up by contacting the command control server and just checking to see if a file called 0.txt exists. If it doesn't exist, sleeps for 60 seconds and tries again until it reaches that particular file or sees that the file exists. Then it moves on to the next step, which would be stopping and disabling all Docker containers. Once that is done, all the prep work is done, the next bash script calls to the command control center, grabs an encryption password, and begins encrypting all of the files and folders that it has listed. And it also reports the status of this encryption process back to the command, or maybe perhaps it's the status at the end that this process is finished. And once that is all done, using, of course, the OpenSSL AES algorithm in CVC mode, that's why I needed to install OpenSSL in the first place, it creates and displays the ransom note. So we see kind of the steps of how all of this comes together. We see the functions here. Now let's dive into some of the scripts by first taking a look at the actual directory structure. This is a prime example, or one way that we can mitigate it is having active search of our systems, looking for signatures or looking for folder names that are being created, or the actual file names that are there is one way that we can actively search, scan, and protect ourselves. So if you see here, you see that there are a number of copies of binary inject1.so, which is, if I recall correctly, a known vulnerability exploit that can be used. But we want to focus here on this API attack because the ransomware that's called DarkRadiation was dubbed to represent all of these scripts in here. So this stuff is not DarkRadiation. This entire, let's say, package here is not DarkRadiation. What's inside this API attack folder is what has been coined the DarkRadiation ransomware. It's a bunch of bash scripts in here. But you see bash decryptor, bash encryptor sh.save, which is a version, bash encryptor 1.sh, code 1.sh, crypt2 first, crypt2 second. You see different variations, different variants of multiple scripts. Now, the Supermicro here under CR is the main script that potentially calls, or that calls all of these other little pieces or snippets, but this is the controller here. Followed by the actual SSH worm is in the downloader folder with downloader.sh. So just on these names alone and potentially the fingerprint of these files, you can have a pretty good method for real-time scanning of your systems to detect this, let's say. So what's the process? First thing it does, as we saw in the visual representation, is it checks for root access. Upon execution, the malware checks if it executed as root. If it did not, it displays please run as root. You see here the check root function. Please run as root, and then it removes itself, and then it exits. So here again are the list of the functions that are being called in the main function. So the next step, as we, if you recall from the visual representation, is the check for and installing of curl and OpenSSL should they not be installed. So it then checks if OpenSSL with the check OpenSSL function and curl with the check curl function are installed. If they're not, the malware then downloads and installs it. So now we're up to mapping users. The bot who function is a bash script that takes a snapshot of the users that are currently logged into a Unix computer system using the who command. So these are all active users that are currently logged in using the who command. It stores the result in a hidden file called /temp/.ccw. Another potentially real-time scanning possibility for us to check whether or not we're being openly attacked by this ransomware. So afterward, every 5 seconds, it again executes the who command and checks the output against the .ccw file. If they're not equal, meaning if the ccw file doesn't have this new user, it logs it. It logs the new user in the file. The malware then sends a message to the attacker via Telegram's API. Once that process is done, it tries to disable and delete all users. Before the encryption process, the ransomware retrieves a list of all available users on an infected system by querying the etc. shadows file. It overwrites all existing user passwords with mega password and deletes all existing users except for Ferrum here. After that, the malware creates a new user from its configuration section with username Ferrum and password meg password blah blah blah. It executes then usermod --shell/bin/no login command to disable all existing shell users on an infected system. So say I log in into the shell, currently logged in. This script is running and it deletes my account, but I'm still logged in. What does it do? What do? They bounce me out. So we're now on to the step, if you recall, within one of the tasks to check the command control server for the 0.txt file to see if it exists on the command control server. If it does not exist, the malware does not execute the encryption process and it sleeps for 60 seconds, after which it tries again. So it continuously sleeps for 60 seconds, checks again until that file is there. Now note that it's invoked using the dash spider option to just check if 0.txt exists in the given URL, and it doesn't actually download it. Now, the way I think about this is it could be used as like some kind of ping, or it could be used as some kind of tracking beacon, so the attacker command control server system can see the connection information from the infected system, as an example. If that comes back, once that 0.txt file exists there, it then begins to do the rest of the processes, like creating the user, Ferrum, changing other users like password to megapassword and then deleting the users, encrypting the SSH, encrypting grep files, encrypting home, encrypting root, encrypting databases, stopping and encrypting Docker, and then finally creating our ransom note message. So to stop and disable Docker, it uses Docker stop, basically stop any container that's out there, and it disables it using disable Docker, system control disable Docker, and then it actually removes the var lib Docker folder, so it can't be started again. The encryption phase. For encryption, the ransomware uses OpenSSL's AES algorithm in CBC mode. The malware gets an encryption password through the command line argument passed by the worm script. So it calls the command control server, gets an encryption password that it can then use. To encrypt all of the files on the system. It is important to note that the encryption path can be different, as I mentioned before, in some versions. So this Supermicro third uses a separate script called crypt_file.sh for file encryption. However, other variants such as Supermicro_cr do the file encryption by themselves. So they're looking at, there's a all-in-one sort of encryption file, which is the Supermicro version, and then there's more modular where it can call crypt_file.sh or some other encryption bash script in order to do the encryption. It is also important to note that the ransomware appends radioactive symbols as a file extension for an encrypted file. So, the encryption phase. During the encryption, the malware sends the encryption status to the attacker via Telegram's API. So here you have the send message function, which uses insecure, the data URL code, takes a text message, it has the message URL, and you see here that they're accessing the URL is api.telegram.org/bot with the provided token. So once this script finishes encrypting and communicating with the command control server, then you get your ransom note, saying you were hacked and follow whatever instructions, blah blah blah. So with all of that, how do we stay safe? The first thing I would probably say is, take a look again at the directory structure, the files that are in there, and see how we can put together a process for auto scanning on change of the system to notice and find these files and either immediately delete them or to at least notify us so that we can pull the plug on all of the rest of our systems, so that maybe only one could be infected and not our entire network. Specifically, if you look at the binary inject.so, you can find it, and you know that it is it's a modified version of the rootkit called lib process hider that hides a process under Linux using the LD preloader and pword.c. Which is a publicly available exploit for CentOS 7 kernel versions. So if you have CentOS 7 kernel versions, as listed here, you are vulnerable to this binary inject1.so. Now, the API attack directory contains the various versions of bash ransomware. As I mentioned before, it's taken on the name DarkRadiation, as well as the SSH worm that is responsible for spreading this ransomware. Now, the supermicro_CR3 script in the API attack directory seems to be the most complete version, of this ransomware. Now, this script is obfuscated with an open source tool called Node Bash Obfuscate, which is a Node.js CLI tool and library to obfuscate bash scripts. So, we have some insight and some details of what we can look for, what CentOS or what operating system version, for example, what CVE is being used to exploit once it's on the system. It's also important to note that most of these scripts in this directory have 0 detections in virus total, which means this can go undetected. So your standard antivirus or standard anti-malware software is not going to find this really. And here we have the SSH worm in this downloader.sh file. It's an SSH worm that accepts base64 encoded configuration credentials as an argument. These credentials would either be dumped by the attacker after the initial foothold on a victim's systems or used as a brute force list that targets systems with weak password protection. Essentially, the malware checks if the given configuration is set to use an SSH password attack on an SSH key-based attack. It can also test SSH passwords on SSH keys against the targeted IP address. Upon successful connection, the malware downloads and executes ransomware on a remote system. So the following is a format credential input to the script after decoding. As you see, username, target IP address, target port, true, use SSH passwords, false, use SSH key, blah, blah, blah. So downloader.sh is how it spreads itself. So locating that, finding a fingerprint that we can use to scan and make sure that that is either immediately deleted or quarantined, or we are alerted so that we can pull the plug is extremely important. Now, more general steps you can take include educating your users. It's not just your secretary, it's not just your project managers, it's not just the VPs, it's also the IT colleagues as well. You want to educate them to spot suspicious emails and activity and contact IT if they are not the right person themselves if they encounter anything suspicious. You want to make time for regular offline backups and test the backups to ensure they can be restored from reliably. We do at least a quarterly test of full infrastructure for most of our clients to ensure that the backups that we have randomly selected can restore, and the entire infrastructure can be restored in a disaster recovery process. Now, we also have offline backups, and what we implement as an offline backup is not something that where I'm like making a backup and then shutting the system down. It's still connected to the network. This is truly a system outside of the network that cannot be accessed from the network, because if the network gets infected and I have an offline server here, as soon as I turn it online to then restore from that backup, the infections can spread to that backup system and destroy it. So we need to have a completely separated offline backups. Think like in some frozen ice cap somewhere on a mountain, or in a safe in the basement. Now, you need to have a plan, and you want to review it regularly. Systems change, requirements change, features change, and new vulnerabilities. This ransomware is brand new. We just found out about a month ago, and new vulnerabilities arise. You want to review your infrastructure and hardware and software regularly. Now, there are a lot of ways to do automatic patching and all that kind of stuff, but it doesn't always run properly. So you need to be able to review your infrastructure. You need to be able to have something in place that triggers and lets you know when hiccups happen with updates or with specific pieces of software or hardware, so that you can ensure that you don't have anything that's end of life. That you're up to date with as many patches as possible, and should patches not be able to be installed because of some other dependency or requirement, that this system is known and can be looked at more stringently in your monthly maintenance of your infrastructure. Whew, that was a lot. You want to update your systems regularly. I'm not even going to elaborate on that. If you're not doing updates, then you're just asking for trouble. Restrict write permissions, especially on things like file servers. if all of the people that are working at your company, if most of them are just, let's say, accessing a file server to download a Word document they need to fill out for their vacations, then they don't need write access. It's just that simple. Use advanced endpoint protection that can identify new malware variants and detect malicious traffic. Now, that is here in this particular episode maybe a double-edged sword, because most of the bash scripts are not found as malware or viruses or infections or anything bad. So for this case, you could say, well, just not going to find it here. But that's why we're looking at other ways that we can, for example, scan and know which files to look for, know the structure, know the directory structure, and actively scan our system using a different method to mitigate this attack. But in general, an advanced endpoint protection is extremely important. A lot of people say, well, you don't need an antivirus or an anti-malware on this kind of system or that kind of system. To me, that's all hogwash. Any system can be attacked nowadays. Doesn't matter if it's a database server that happens to be accessible over the internet, which I would strongly advise against, or a web server, or just some middleware for an app or whatever. They can all be attacked. They can all be used in a ransomware attack, or in any attack for that matter. So endpoint protection, of course. Use an email and web protection to block access to malicious websites and scan all downloads. So with phishing as being one of the primary and easiest ways to gain access or gain somebody's trust or make somebody make a mistake. You get an email from a bank and looks like you're a bank, even though the link goes to some crazy domain, and you're not really paying attention. It's Monday morning or it's Friday afternoon, you want to get home, but you get an email from your bank. If you click on it, boom, you're infected, boom, they're on your system, boom, they're in your entire infrastructure within minutes. So email protection and web protection. You want to use at least a 2 firewall based system. That means an external firewall on your network as well as a local machine based firewall. Now, there are some ransomwares out there and malware and hackers that disable the local firewall on the system, but if you have the network based firewall, you're still protecting your system. And it's not just from coming in, it's also from going out. So all of these ransomwares are contacting an external command control server. So if your firewall is set up to restrict outgoing connections, then they cannot communicate with their command control server. So now let's say, okay, well, if I have put these rules on my machine itself and they turn off the machine firewall, then they can get out of the machine. Yes, they can get out of the machine, but if you have a two firewall based system with a network based firewall with similar rules, they can't get out of that firewall. So, restrict outgoing connections where possible. Now, this is exactly what I was just talking about in terms of the firewall. This will limit the ability for these attacks to contact their command control servers, thereby negating the attack. One of the first things it does is try to contact and look for a 0.txt file. It does not do the encryption until it can actually reach that 0.txt file. If it can never reach the 0.txt file, it can never do the encryption. If it can never reach the command control server, it can never get the encryption password to even do the encryption on your server. You want to disconnect from networks immediately if you suspect infection. It's better to pull every plug out and be offline for a couple of hours with a false alarm than to be offline for months or potentially out of business because you have no backups and you can't get back online. Finally, you want to get insurance. Now, there's a lot of talk about, well, you should never pay the attackers. U.S. is trying to enforce that you're not allowed to pay ransoms to ransomware groups because it only eggs them on and shows them that it works. So look, you have a business decision to make here. In all of the cases that I've seen where people have paid, insurance has covered at least a portion of that payment. So sometimes you're talking about millions of dollars that doesn't come out of the company's pocket, but the insurance covers. That now, if you pay it, again, that doesn't mean that you're okay again. If they give you a decryptor key, these guys spend so much time in terms of encrypting, and they just make a dummy little script to decrypt. But depending on how much data you have, it could take weeks, it could take months, it could take years to decrypt because the process is much slower. So just because you pay and you're like, okay, now I have the decryption key, doesn't mean you're in the green, doesn't mean you're back online. It still has to decrypt everything and get you back online, and there's still no guarantee that the the decryption key is going to work 100% for whatever reason. So take it with a grain of salt, but it's better to be safe than sorry. If you have life insurance, your company should also have a type of life insurance, which I would say should cover something like ransomware. So with that, thanks for your attention. Don't forget to share this video. I hope you learned something. I hope you enjoyed it, and I look forward to seeing you on the next episode. Take care.
Don't forget to ride!